Are you ready? Going through, coming down, right through, yeah. Basic underlying principles of a roller coaster start with one of the more fundamental laws of all of physics, and that is the law of conservation of energy. When we start to talk about the law of conservation of energy, what we're really dealing with is a situation that we know that in a closed system, the energy is conserved. And what that means is that energy is transformed from one type to another, but the total amount of energy stays the same. Energy is defined as the ability to do work, and so what that begs is then a definition of work. And work is the idea of moving something by using a force on it through a distance. At the bottom of a roller coaster, the object has no potential energy. The train has no potential energy. So what we have to do is we have to supply energy to the system to bring it up and give it energy. So the machine is adding energy, supplying a force. That force is moving the object through a distance, and that's what we call work. On a roller coaster, what we deal with are two basic types of energy called potential energy and kinetic energy. Potential energy is the type of energy of position, and on a roller coaster we're talking about gravitational potential energy because we're dealing with the height that a roller coaster might attain. With kinetic energy, what we're dealing with is the energy of velocity or speed, and so as an object gains speed, it gains what we call kinetic energy. And then as we get to the bottom of the first hill, we're projected upward again by the track into another hill. At that point, we're losing speed and gaining height, and so throughout this entire process, it's one series of conversions between potential energy and kinetic energy after we do the initial work to get the system to a spot of energy that we'd like.